Good morning everyone. My name is Aneesha Gogineni. Today I'm going to talk about optimum design for cartridge filter cleaning systems. Highly efficient air filters are expensive air filters and they can filter 99% of the dirt particles. Commercial diffusers are usually looking for low cost and high filtration capacity units. So keeping the physical figures in mind, health and safety, commercial diffusers are just maintained at the optimum filtration capacities. The present study focuses on the filtration capacities of two models, Model A and Model B. As part of the study, number of particles that are trapped in the diffuser, number of particles that are returning back to the compressor, number of particles that are leaving the system were all calculated at different pressure values. The two models are named as Model A and Model B. Their filtration capacities are 80%. That's an assumption that we have made. The diameter of the filtration hole is 0.3 microns to 10 microns. The flow rate of air in CFM is 250. As you can see the figure here, this region indicates the dirt air that is entering the system, and this shaded portion is the filtration capacity. There is air that is flowing through the system here. It's the entrance, this is the exit, and the only difference between the two models is that this unit has another compressed air spray unit. You can see this one. So this region is not there in Model B. So there is a cost associated with this compressed air sprayer, and some of the particles are trying to return back to the compressor here. So this indicates that there are some advantages associated with Model A and some advantages associated with Model B, and same with the disadvantages. This slide shows particle distribution of Model A, and this column, the compressed air, the particles that are returning back to the compressor, refers to this one. So absolutely there are no particles that are returning back to the compressor in Model A. We can see that there are particles that are trapped in the diffuser because of the filtration capacity, and which is normal. There are also some particles that are leaving the system. This refers to the particles that are leaving the system. This one refers to the particles that are trapped in the filtration unit. So this is going to be different for Model B because there is no compressed air sprayer. The pressure increase in both the models are pretty much similar. So there is no effect of pressure really. It depends on the application they are using it, but technically the trend of the way that if we increase the pressure, the way the particle distribution changed just similarly in Model B as well. So here this column, the compressed air inlet, refers to all the fluid that is going back, all the particles that are going back. Whereas the trapped ones indicate that these are trapped here in the filtration unit. Now there are particles that are also leaving the system, which refers to the exit of the diffuser. So like I said, it is pretty common to have particles trapped because of the filtration capacity. But in Model B, the only observation we have noticed is that the particles are going back to the compressor, which could damage the compressor after a certain period of time. From these graphs, we can notice that this Model A has absolutely zero particles which are going back to the compressor. And when it comes to the way that particles are getting trapped inside the diffuser are pretty much similar in both the cases. So, but still, when you have to compare the number of particles that are trapped inside the diffuser, Model A showed higher amounts of the particles that are trapped inside the diffuser when compared to Model B. Here are some of the advantages and disadvantages we have noted in Model B and Model A. Model B has a simple construction and they're comparatively cheaper. Their design is also simple. They do not require any additional motor or rotating device. This entire system is less complicated and does not require much of maintenance. Whereas Model B has a big disadvantage, which is when particles are returning back to the compressor, there is a possibility of replacing compressor after a certain period of time, and this is included as an overhaul cost. Also, with time, dust particles coming into the compressor outlet might block the compressed air passage, so choking of the compressed air would occur under such circumstances. Advantages of Model A includes that there are no particles that are going back to the compressor inlet, so there is no replacement cost. The disadvantages that we have noticed in Model A is that it's a bigger construction because it has an additional sprayer. It is more complicated, it has higher cost, and at some point if the sprayer requires some maintenance, so there will be overhaul cost associated with Model A. In conclusion, we have noticed that Model A has better filtration capacity, and it also has a compressor that can remain in the system for a longer time. The disadvantage is that the construction is complicated and it has some cost associated with that, whereas Model B has an advantage of having a simpler design and that being cheaper. Whereas the disadvantages is the big disadvantage we have noticed is that the compressor replacement cost is associated with Model B. If a company really wants to use Model A or Model B, an engineering economic analysis is required in order to exactly compare the cost associated in both the models. If you have to choose just between the filtration capacities, Model A is the better filtration capacity. But if you're looking at the cost associated, from our understanding, we haven't done the engineering cost analysis, but from our understanding, it's that the compressor cost might not be as much as the construction cost associated with Model A. If a particular company really wants to decide between the two models, then they definitely have to do the engineering economic analysis to compare the cost associated with just the maintenance cost with the sprayer versus the replacement of the compressor. For any other further questions on this presentation, please contact Aneesha Gogineni or Dr. T.S. Ravigururajan. The email IDs are provided, so please feel free to contact us anytime. Thank you so much for watching my presentation. Please let me know if you have any questions. Thank you.
Thank you very much, co-host. Are any representatives of this paper here on the chat?
I just saw a message there that the TS Ravi is online. You should be able to answer questions on this presentation. And I have is TS Ravi here? Hello?
Hello?
Yes. I have one question. Can the model be used for optimizing a natural gas filtration system as well?
No, yeah, you should be able to use, provided you know the particle size, the distribution, and all those things. Usually gas filtration systems should be much less contaminant particles. This is for industrial use. Naturally, it is got more contamination, also the pore size and everything. When you're talking about gas filtration, you're talking about much smaller particle size and probably much purer, less contaminant. So you may have to, redesign the filtration a little bit because this may be too large for that depending on the particle size. Are you able to hear?
Yes, thank you. Thank you very much for the response.
All right.
Dr. Thompson, no more questions from the chat.
All right. Thank you.